Hello and welcome back, my fellow tech warriors. This is Lab 404, signing on. In this chapter, we're focusing on troubleshooting PC hardware issues. Troubleshooting is not about guessing. It's about following a structured process, understanding how hardware initializes, and knowing which symptoms point to which failures. We'll cover firmware issues, power and storage failures, system instability, and display problems. First, let's talk about firmware, BIOS and UEFI fundamentals. Every troubleshooting process starts before the operating system ever loads. Firmware, either BIOS or UEFI, initializes hardware, performs post, and locates the boot devices. If firmware fails, the operating system never gets a chance to load, which means many problems happen before the operating system even appears. Now, you're going to want to know how to access your firmware. Firmware settings are accessed during the boot process, usually by pressing keys like Delete, F2, F10, F12, or Escape. Modern systems boot very quickly, so if you miss the prompt, you can always restart into firmware settings through the operating system's advanced startup options. One of your first main common issues are boot order issues. One of the most common firmware issues is an incorrect boot order. Firmware checks devices in a specific sequence, such as internal storage, USB devices, optical drives, or network boot. If the system is trying to boot from the wrong device, you may see messages like no boot device found, even though the OS drive is perfectly healthy. Next are ensuring USB permissions. Firmware can enable or disable USB ports entirely. This is often used for security to prevent unauthorized booting or data access. If USB devices are not recognized before the OS loads, firmware USB permissions should be checked. Now we have cooling and fan settings. Cooling configuration is critical for system stability. Firmware allows you to control fan behavior using profiles like balanced, quiet, performance, or custom curves. If fans are misconfigured or airflow is poor, heating can cause throttling, crashes, or unexpected shutdowns. We also have Secure Boot. Secure Boot is a UEFI feature designed to prevent boot-level malware. It works by allowing only trusted, digitally signed bootloaders to run. If Secure Boot is enabled and an unsigned operating system or recovery tool is used, the system will refuse to boot. Now, diagnosing power failures. If a computer will not power on or shuts down unexpectedly, power is the first area to investigate. The power supply, which converts AC power into multiple DC voltages, will send a power good signal to the CPU once voltage is stabilized. If that signal fails, the system will not post. Now, to diagnose a no power issue, always start simple. Check wall power, test with known good devices, verify PSU switches and cables, and disconnect unnecessary hardware. Power supplies are not user serviceable. If one is suspected faulty, replacement is the only correct solution. We also have post failures, or power on self-test issues. After power is applied, firmware runs the post, which is a basic diagnostic check. If fans spin but there is no display and no beep codes, post may not be executed. Causes include faulty RAM, CPU, motherboard, firmware corruption, or improper cabling. Some PCs have beep codes, which are post error indicators. When post detects a failure, it may use beep codes instead of video output. These codes vary by manufacturer, so always consult vendor documentation. Beep codes almost always point to RAM, CPU, or video problems. You also have boot device problems. If post completes successfully, firmware searches for a bootable device. Errors like operating system not found usually indicate boot order issues, disconnected drives, or corrupted boot data. NVMe and SATA drives must be detected in firmware to be bootable. Next, let's discuss boot record formats. You have MBR versus GPT. There are two types of boot record formats you must know. MBR is legacy, limited to one active partition and smaller disks. GPT is modern, more reliable, and required for UEFI secure boot systems. We also have system crash indicators, or OS crash screens. Once the operating system begins loading, failures usually present as a crash screen. In Windows, this is infamously known as the blue screen of death. These are often caused by driver issues, memory faults, overheating, or power instability rather than firmware problems itself. Now, there's the scary one, storage device failures. Hard drives and solid-state drives fail differently. Hard drives may click or grind, while solid-state drives may fail silently. Missing drives, read or write errors, constant disk activity, or boot failures all point towards storage problems. But alas, we have a solution for that: drive health monitoring, or smart diagnostics. Most drives support smart monitoring, which tracks error rates and failure indicators. Rising error counts indicate imminent failure. When smart warnings appear, immediate data backup is the only correct response. Another storage-related failure is RAID failures. RAID improves availability and is not a backup. A degraded array means one disk has failed, but data is still accessible. If too many disks fail, or the controller fails, the entire array could be lost. Now, system instability, random crashes and lockups. Random reboots, freezes, and crashes are often caused by overheating, unstable power, or failing components. Always identify patterns, and problems that worsen over time often point to thermal issues. Now, to diagnose thermal issues, or overheating. Overheating can cause throttling, shutdowns, and permanent damage. So always check fans, heat sinks, thermal paste, airflow, and environmental conditions. Burning smells or smoke indicate immediate shutdown is required. Then there's hardware damage, or physical damage. Physical damage often affects ports, connectors, and cables first. Inspect for bent pins, broken connectors, liquid damage, scorch marks, and swollen capacitors. Electrostatic discharge, power surges, and improper installation are all common causes. Another common issue is performance issues, or slow, sluggish systems. Performance issues are not always caused by weak hardware. Misconfigured RAM, thermal throttling, slow storage, or driver problems can all reduce performance. Remember that a fast CPU paired with a mechanical hard drive can still feel slow. Next, there's date and time problems, or RTC battery issues. If a system loses time or resets firmware settings when powered off, the RTC battery is likely failing. This coin cell battery maintains system time and firmware configuration data. Replacement is the correct fix. Now, blank display issues, or no video. Always start with the display itself. Verify the power, input source, and cabling. If needed, always test with a known good cable, a good monitor, or system to isolate the failure. Another type of display problem are projector problems. Projectors may fail due to overheating, blocked ventilation, failing bulbs, or just a loose connection. Intermittent shutdowns almost always point to thermal issues, and always allow projectors to cool before you service them. Another type of display issue are video quality issues, or display defects. Fuzzy images usually mean incorrect resolution. Flickering or color distortion often indicates cabling or GPU issues. Burn-in affects OLED and plasma displays more than it does with LCD or LED screens. Now, back to the troubleshooting methodology. These are kind of like your roadmap to solving problems in the field. Successful troubleshooting follows a method. Always identify the problem, establish a theory, test the theory, implement a solution, verify functionality, and always document findings. Now some key takeaways. You always want to start with power and physical connections. Know where the boot process is failing, whether it's with the firmware, host, bootloader, or operating system. And remember, RAID is not a backup. Overheating can cause instability, and Secure Boot can block recovery tools. Mastering these concepts prepares you for the exam and real-world IT support problems. Now, that's mission complete, and I'll see you in the next system breakdown. This is Lab 404, signing off.